right, good morning, everybody. My name is Andrew Bowerbank, Elliston. Pleased to be here. You know, I've been involved with the festival since we first started talking about this back in 2003. And it's amazing to see how this festival has grown, the interest, the people in the audience, the size. I remember when we first started doing it, very, very small venues. And this plenary session coming up, I think, is a very important one, preparing for net zero. One of the things that we've probably all noticed over the past, I would say, 6 months, maybe even a year, is the term net zero has become quite a buzzword. And a lot of people are using it as that next catchphrase of targets, of possibilities to achieve. And I think we have to be very careful about how we're using the word and how we're building and trying to target a net zero energy building, a net zero energy community, whether it's even energy or even emissions. But what really caught my attention was about 3 months ago, I got called by the federal government, NRCan first, to do a session in Ottawa coming up on November 14th. And this is with the RPIC conference, where it's all the real property people getting together to talk about how are they going to build to these new aggressive targets. And the question was really around, could I host a workshop that demonstrated to federal leaders that the industry is ready to build to net zero energy? If they start doing policies and regulations that start driving us towards this new level of efficiency, is it going to put a pause in the market, or are we going to be able to achieve these targets? And that spoke volumes to me, because I think most of you know me anyways, at Elliston, we launched an initiative a year and a half back, maybe 2 years ago now, called the Carbon Impact Initiative. And we got some of the largest companies in the country working with us, BASF and Cricket and in Ontario, and Enbridge, who's been a great supporter, Avison Young, and just a lot of great companies. And really all of us coming together to try and bring the resources together that if we're going to build to net zero energy, it's not going to price it out of the market. We've got to make sure we can do this well and efficiently. And I think what we're talking about today, to achieving net zero with tomorrow's challenging climate, is a big issue for us to try and make sure that we're not just trying to brand something and to say, oh, look, we're leaders in net zero energy. This is something that is real. We have an international commitment to the United Nations now to help achieve 80% reduction in emissions. And sometimes if you think about what that means from a Canadian perspective, what I've been told is like every building in Canada being LEED Platinum. Right? It's a little bit of a daunting task. And I think with the session coming up, we've got the right type of leaders talking about this. I've known Mike for many, many years, a great leader in this area. We have to really make sure that we know what we're doing. So us at Elliston, we're very proud to be supporting the Green Building Festival, supporting this session specifically. So Larry's going to come up and introduce everybody, but please enjoy, and pleasure to be here. Thanks.
Okay, if I could ask our panelists to come up and join me on the stage here, please. All right, our first speakers are Mark Cichy, Director of Computation and Research, and Tristan Truyens, Senior Energy Analyst for DIALOG. They'll be talking about leveraging computational design for high-performance building envelopes. Mark, I believe you're starting us off?
Actually, Tristan will.
Tristan is? Go ahead, Gary.
Thanks, Larry, and thanks everybody for being here. It's a really exciting day. I'm looking forward to all the other presentations, so I'll dive right in. I'm Tristan Truyens, this is Mark, and together we'd like to share with you some of the exciting work that we've been doing particularly in the commercial building sector at DIALOG, with using computational design methods for improving both energy efficiency and form of the building envelopes that we work with. Going down this plenary in preparing for net zero, we've separated the presentation into sort of 3 simple questions to tie it all together. Where are we now? Where could we be? And are we there yet? So just try and keep those in mind as we work through. For those of you that aren't familiar with DIALOG, we're a interdisciplinary group of architects and engineers who truly believe that design can improve the communities and environments that we all share. And where Mark and I tie into this is by assisting our design teams by providing building performance technology to really help bring the ecological footprints of our designs as low as possible. Now, I personally only began to appreciate what computational design was and how powerful it could be when I met Mark, when he joined our firm about a year ago. And I'm assuming there's probably a similar level of knowledge in the room. So we're going to start you off with a little computational design 101 so that we can all move forward through the rest of the presentation on the same footing. So Mark?
All right. There's a clicker. I guess the giant green button is go. Right, so I thought I'd start with a brief definition. I was told to be in the weeds, so we're going to be in the weeds today. Computational design essentially sounds like a very technical term, but essentially what it is connecting the variables and the elements that define design and using those variables to create architecture or address performance factors in a building. So give you an example. You may want a specific type of performance on your facade. Given historical information performance data, we can tie the performance data to the live design and actually use that to influence our decisions while we're sculpting the building. Doesn't really change the process of how we do things. I mean, these are some of my sketches. All they're meant to represent is the fact that there is a form that we're trying to achieve. And the form is actually driven by a series of variables. And so what we're doing is we're defining elements of the design instead of saying that they're a derivative of some sort of artistic factor. They're actually driven by hard-coded metrics. So this is a video that we have that actually shows sort of what the interface looks like. And this is a kind of proposal that we were working on with Elaston, actually, that was showing different massing possibilities and strategies for a segment of a site. And this was meant to incorporate and consider factors like autonomous vehicles, reduce vehicular traffic, and what it's meant to do is actually present both the designer, contractor, but also the client with a sense of dynamic feedback. So as you're doing the design, what you're seeing is there's a heads-up display that actually gives you your performance data as well as your areas, anything related to construction or the building in general can be defined as a dynamic variable that helps you through the process of design. So as we kind of move forward, we have all of these kind of interesting technologies and these ways that we're trying to design buildings, but this is where we're still at. 100% glazed facades, which are obviously not a very high performance building type. So what we're trying to do is address that and make it a high performance building type.
And the goal here, or the idea, is not to call out these buildings as being particularly bad. Both of the designs that we just showed achieved or are pursuing high levels of certification through the LEED program. And were really designed by teams who were trying to do the best that they could with the paradigms of the design, parameters of the design that they were working with. I think it's important to note at this point that these are somewhat the product of energy codes and standards that have set a line for performance where we can still trade off a poor thermally performing envelope with better but less permanent systems within the building. So you're swapping out you're keeping 100% glazed facade, but you're driving really low lighting power densities. You're really maxing out your HVAC efficiencies. And unfortunately, those systems can somewhat be temporary or to the whims of a tenant or future retrofits. It's not always going to be like for like, and this tends to lead to drift in building performance over time if they're not properly maintained. Whereas a really well designed, detailed, and installed section of opaque wall should really last and continue to perform at its design level for the life of a building. But the good news is that this isn't really a technology problem, because in the more institutional sector, having really high performance elements to your building envelope is not necessarily the norm, but is much more accepted already. Some examples, the building you see now, the new Central Library in Calgary, while still being a 100% curtain wall building, is only 35% vision area, and that vision area is all triple pane glass. The opaque areas have vacuum insulation in the spandrel to really try and maximize the thermal efficiency that they can while still giving that sleek curtain wall look. At the EO building at the University of Calgary, there was a desire to have a really, really well daylit space, and so these very engaging shading elements were added to make sure that there was adequate solar control, so that low temperature, or high temperature actually, cooling systems could be used without the impact of that over solar loading. With the Royal Alberta Museum, there was the idea again of keeping the window to wall ratio as low as possible. So glazed areas were clumped around the big feature lobby and reception areas, while maintaining a very highly insulated opaque section. This has also really helped control for the strict environmental requirements that are inside gallery spaces in museums. And finally, a sort of different way to deal with that solar loading issue at the new international facilities project for the Calgary airport, in areas where there was expected to be really high solar loading. Sections of double facade were added that could open at the top to reject heat by a local stack effect in the summer, and also provided a passively heated kind of greenhouse buffer space during the heating season.
Okay, so this was actually a quote from one of the principals at our firm, Martin Sparrow, whose primary client base is in high-rise commercial. And essentially, the gist of this is that with the upcoming restrictions and policy changes that are going to redefine how we can actually build these sorts of buildings, we need to essentially educate our clients. So what we're going to show, I guess, after this, and kind of as we progress here, is what we've kind of developed to try and help educate our clients. Because obviously design is your first kick at the can in order to actually address performance and build for a sustainable future. But before you get there with this specific client, there's a sense of education that kind of needs to be had in terms of teaching them that it may not necessarily cost more, or the value and the return is actually there, they just don't know it yet. So there's a quick video here that we have that essentially helps us anyway study. Now our client totally doesn't understand this because this is a dynamic. Yeah, that's funny actually. Everyone's laughing. No one's done that before. And this is a room full of geeks. So what we're doing here is we're actually limiting different targets, and we're trying to explain to the client as we're targeting this, is we're saying, you know, what are our overall energy targets? What is the standard we're trying to achieve? And this is just a graph that plots what our possibilities are, what our number of possibilities are. So obviously if we're looking for something that's significantly high performing, the thread is going to get very thin, right? But as we go ahead and we kind of broaden our horizons and we start to incorporate things like systems into this, then we can start to address the different elements.
I mean, so are we there yet? There's been a lot of talk of future codes, standards, and rating systems that are coming out that are really driving energy efficiency even deeper into what's necessary for building design. And with a lot of these, particularly things that are ratcheting upwards, like the 2030 challenge, new targets under version 4 of LEED, are pushing that bar low enough that things are really going to have to start being addressed at the building skin. We're moving beyond the regime where we can just trade off fancier systems and control routines on the inside of the building, and need to start building a more resilient thermal envelope on the outside. I remember when the 2012 version of SB 10 came out, and thinking like, oh, well, that's the end of window wall condos. But it clearly hasn't happened after 5 years. And so that there really is that feeling that there's something that needs to be pushed a little further to make sure that we are actually building these buildings that have, you know, a degree of passive survivability and are truly resilient. And even some of these new codes, particularly City of Vancouver's new energy standard, as well as the CAGBC's Carbon Zero Building Program, are starting to include metrics that have to be met that exclusively address the building envelope, thermal energy demand intensity, or TEDI. And I believe it is coming quite likely to the new Toronto Green Standards. So it's something that the industry as a whole is going to have to really wrap their heads around as far as just what these high-performing envelopes that are needed are going to look like and what it's going to take to put them all together.
So what does big data have to do with all this? Mike, I'm sure will be able to talk to that. But essentially, all of these standards that have been and are being developed, policies that are being developed, building performance, pre-design, design, post-occupancy. You know, we have a couple of initiatives going on right now where one of our projects in Vancouver, the Nest, we're working with researchers to analyze Wi-Fi patterns to understand and compare those against building heating and cooling loads, where people like to sit, so psychometric analysis. All of this information we're actually warehousing and we're keeping track of. And our systems that we're showing you computationally in our design systems are actually informed by these things. What you're seeing on the, in the graph there is a series of active connections. This is a machine learning graph that is actually adapting as things are happening. So as we pull in live information from all these various sources, whether it's design that we're working on within the studios, or whether it's coming in from this research Wi-Fi analysis of the Nest, these connections actually populate new metrics. And so we start to understand what is connected to people, buildings, performance. All of these things actually start to develop autonomous relationships with one another, which is really interesting and is really helping us guide the way that we design buildings because it helps push us in directions that we may not have thought of previously. So this is a project, again, with Ellis Don, Andrew, we just met a few months ago, where we use this building as a prototype. So this was a design build with Ellis Don. And what we did was we used this building, again, as I said, as a prototype to kind of study, and this is a video actually, so I'll just talk over this video, that shows how we're analyzing solar radiation gain at the same time that we're actually using that information to design the building's facade. So this was a post-design analysis. So what we did was we used this as a case study to try and figure out, you know, what could we have done with our unitized glazing units versus our solid panels? If we had to put shading devices or extruded mullions, how much energy would that have saved? How much shadow could we have cast? And you can't really see it, but in the bottom right corner of the top left window, what we're doing is we're actually calculating in real time the cost that's related to these decisions. So we have a concept of design, we have a concept of performance, and we have the context of the local municipal cost of something like that in that market. So I'll just go to the next slide. So this is another example where we used computation to essentially design the building's form based on performance factors. So in the top right corner, what you can see is how we graphically step through different iterations of the design. And below that, again, is you see that wire diagram that essentially establishes all those connections that harness the information that helps us define the shape of that building and what that means for performance and orientation and, again, psychoanalysis. What this is a student residence, so how people share rooms, how they perceive space, right? And lastly, I mean, this is our target, right? It's kind of scary when you start to look at an entire city of glass and you think, how are we going to make that better? So when you look at some of the older buildings here, you notice something that's quite different than some of the newer buildings, right? And so what we're trying to do is strategize and show our clients that you can still make beautiful design without having to make everything in all glass. So essentially, what I'm showing here is essentially a quick little diagram that explains how we warehouse information. So on the left, we have our big data, our database, which harnesses all of the information that we're pulling from. From there, we have static data, which is the little circle, white circles. So that's information that we can key in that we know historically through 60 years of practice, we know works, right? That stuff, for the most part, doesn't change. So that's static. Then to the right of that, you have these little sliders. And those are elements that have ranges that we can actually play with to help us dynamically define how the design and the systems work and how we can incorporate. So it allows us, just like that graph you guys saw where we were charting the trajectories of our possibilities, we can do the same thing with the standards or performance that might be available to us based on, we may select one type of system, VAV or something like that, for example, which might have an impact on and define what our options are in terms of glazing performance down the line, right? So these are all the things that are dynamic. Then what we do is we chart that into our system, we bring it in, and that defines geometry or form. Well, it doesn't define geometry or form, but we use that to make decisions on what the building looks like and how to plan the space. And then through those decisions, we find out that there are problems and we need to redefine those. And so we go back to the beginning, and that's the iterative process of design. It's just a little bit more informed now. So lastly, the last video we have is essentially visualizing, and you'll have to bear with us because this is still kind of very much in development, so the graphical user interface is a little bit rough. But this is what we're using to talk to clients, where we sit down and we have a series of baseline metrics, and we say, okay, we're going to target LEED, or we're going to target 2030. What is what are some options we can use if we choose a window wall ratio of a certain factor versus our R value for our envelope, and what is that return in terms of EUI reduction based on what those decisions are. So you can see as we kind of move through here, and on the left you'll see the red is solid, the blue is the glazing, but as we start to discuss different levels of opaque facade and vertical columns, so we can do exterior exposed vertical columns, we'll obviously see that our reduction will go up, right, because we've got less glazing. So we're just trying to educate the client to say, and obviously we wouldn't present it to them in this manner with some ghastly solid columns. We would actually create something that's a little bit nicer. But this is just meant to illustrate that process so that we can have those discussions with our clients and say, look, we can do this well, we can make it look nice, and we can still achieve the standards that we need to in order to make this a better place for everybody ultimately, and obtain our targets as per our agreement with the Paris Accord. So I think, yeah, that's pretty much it for us.
Thanks.